Hey, today we're going to talk about a design methodology called activity diagrams. And I first learned about activity diagrams in a really great book by Dr. Kevin Otto and Dr. Kristen Wood. Actually, Dr. Kristen Wood was one of my professors in grad school, and his class was really amazing, and he really exposed a lot of these design methodologies to me, including activity diagrams. So I really recommend that book, and the book is called, like I said, Product Design. If you want to look it up, it's called this. You can find it on Amazon. But it's a textbook full of other methodologies, and we're going to talk about just this one. And it's a methodology that you can use for a lot of design purposes. But before we talk about how it's used, let's just figure out how to make an activity diagram. The way they talk about it in that book that I just mentioned is in the context of reverse engineering a product. And so here I've got a fancy little product here, which is kind of disturbing if you don't know what it is, but we're going to reverse engineer it real quick. So I just showed you that it's got like this battery section. It jiggles when I turn it on, when I press this button. It has 3 settings. It's going really fast right now. And you've got this modular component that pops on in. This is actually a product that I found for that graduate school class to try to analyze a bit. But when you plug in this modular component and you put it on something and you press the button, it starts vibrating. And you see what it's doing? It's spinning around, and it's erasing my words, and it's doing all sorts of things. And I'm not going to leave it on because it's really noisy, but like I said, it has 3 settings, which changes the motion pattern. And this black or gray surface that you're looking at, this is a silicone grip. And likewise, you've got silicone coatings along the feet of these metal prongs that come out of the modular component. So what this product is actually called is a sauce stirrer. So if you go into the kitchen, you could put this thing in a pot of tomato sauce, for example, turn this thing on, and as the heat is on, it's supposed to just sit there and spin your sauce so that you don't have to take your old-fashioned wooden spoon and stir it. That's what it's supposed to do. That's what this is supposed to do. And so we're going to try to represent the way it works, we're going to try to represent the way a user is going to use this thing with an activity diagram. So an activity diagram represents how a user uses a product. If I'm the user, how am I going to use this product? So I'm going to put on my thinking cap and imagine, okay, what am I going to do with this? Well, as a user, I might pick it up. So I'm going to write down a verb representing what I'm doing. So pick up device, we're going to call it, or stir, and we're going to put that in a little box. And then what else would I do with this? After I pick it up, I might put it in my surface. I might place stir inside a pot, something like that. Or I might place the stir in a pan. Where else might I put it? Because this thing is so ridiculous, I'm just setting myself up for strange answers, but I'll just suggest place it in a cabinet. Or you know what? I've decided that's too specific for me. As for an activity diagram, I want to be pretty general, so I'm going to say store the device, because I could put it in a cabinet, I could put it on the table, I could put it in the cupboard, and I don't want to write that out a million times. I'm going to say store device. That helps encompass everything. So what else am I going to do with this thing? I have arrows pointing to the sequential logic of what I would do. So after I put it in a pan, in theory, I might press that button on top. But again, like I said, I don't want to be so specific. I just want to say generally, what am I doing? I'm turning it on. I am power on device. That's what I might do. And you can see that I'm converging in my actions here. So each one of these boxes, I call them user actions. In that product design book, they call them user activities. That's why it's called an activity diagram. I'm just diagramming out in this fancy flow chart all the activities that I, as the user, am going to perform on this object. So after I turn it on, I may just look at the device as it's spinning, because I want to know, is that thing going to catch fire? Is it actually spinning? I might adjust position, stuff like that. And so I could just keep on going. There are other things that I could do with this thing. Eventually I'll have to turn it off, so I'll include that. Turn off or power off the device. That's a pretty important one, so that's something I'm going to include. And eventually this could become a really, really rich diagram. So what this diagram does is it helps you break down your system in some sense. If this is my system and I want to know everything that I, as a user or a generic user, will do with this thing, I gotta document it all, because that information is going to be useful later. For example, maybe I want to, in this case, reverse engineer this thing. I want to make it better. So I need to make it better in all these different ways. Better way to power it, better way to be visible, better way to balance itself in the pan, better way to pick that thing up. And I can just, as I redesign everything, just check it off. Oh, I made this better, I made this better, I made this better, I made this better. So each one of these boxes gives me an opportunity to brainstorm about creative redesign ideas. It gives my team an opportunity to create a test for my final design to make sure it passes each one of these important tests. I should be able to turn it off easily. I should be able to store it easily. Another thing that we should think about when we discuss activity diagrams is, historically, engineers haven't always looked at the entire activity diagram. What's missing from this activity diagram? Well, we haven't talked about buying the device. That's an important part of the whole process of using this. Maybe transporting the device. As the user, how am I going to carry it around? Am I going to get it from Amazon.com? Am I going to get it by driving to the store, something like that? And then what about the other end of the life cycle? What about throwing it away because this thing may be useless? Throw away? Oh, but I need to be more general, because maybe I won't throw it away. Maybe I'm going to recycle it. So what about two different options for the end of the life cycle? Maybe I can recycle my product as one thing I can do with this thing, or I could repurpose it. Maybe this becomes a cat toy. Maybe I'm not going to stir any tomato sauce with it, but I'll just entertain people with it, And, there's always that option of dispose of it. So like I said, historically, engineers may not have thought about what the user is going to do before and after the main part of their device. Maybe that's why we didn't think about bio-friendly or eco-friendly plastics, or we might not have thought about the packaging that went into selling this thing, or the batteries that might go in and out. There's other actions that are missing from here. Put in the battery, take out the battery, all that stuff. And so if I include everything in my activity diagram, I have a nice checklist and systematic way of analyzing my design. By the way, we don't just make a list. I could have just listed out all the user actions. We made a logical sequence. So another thing you can use this activity diagram for is rearranging the sequence of stuff. Maybe I notice that there's a linear flow of user actions, and maybe I want more choices in there, so you'd want more branches. Or maybe I have too many branches. Maybe it's too ridiculously complicated and I want to simplify or streamline the user experience. The activity diagram helps us see that. So this is a very simple technique that anyone can do at any age to analyze a product. Check out some other videos to think about activity diagrams in more depth. Thanks.